to solve first order differential equations. So there are four types of differential equations, or sorry, there's five types of differential equations that we're going to encounter. Each time comes with its own solution technique. I mean, you know, I said, what's the rationale if you want to solve a first order equation? What do? You integrate once in some sense, but it's a little bit more complicated than that. All of the equations will ultimately come down to us integrating something, but generally speaking, we're going to need to do something to prepare them first. So,
You got one for me? Nope.
so what sorts of things will a first order equation contain? Let's say the dependent variable is y and the independent variable is x. What sorts of expressions? If it's first order, that means what?
First power.
There must be y primes, right? Then you might also have expressions containing both x and y, okay? So the most general form of a first order equation, if you were to isolate the derivative, the most general form is y dx is equal to some function of x and y. Okay, so any first order equation can be written this way. All you do is isolate the first derivative and solve for it. Okay, so let me see here. So we've worked a couple so far where if dy dx was equal to not a function of both x and y, but just a function of x. Okay, in that case, all that we needed to do to solve the equation was integrate with respect to x. Right? We just did one. We just did two of them here. So let's say instead of being only a function of x, we have an equation that looks like this: dy dx is equal to x plus y. What's the goal? Find y. We want to write y equals some function of x, right? So we could maybe attempt to remove this derivative by integrating, right? So let's attempt to integrate this equation with respect to x. Okay, what is this?
Y.
This is y. Okay, let's split this into two. X dx plus. Okay, what is this?
Y half x squared.
Yep, so good so far? What is this?
Yx.
We need to be careful here. What is y? We're thinking of y as some function which depends on x. So let me be more precise and write it this way. So let me ask the question again. What is this? We have no idea, right? It's like asking, what's the derivative of y? Well, I don't know what y is as a function of x, so I can't tell you what the derivative of y is, right? So in the same way, I can't say what the integral of y is because I don't know what y is as a function of x. So we've traded one problem for another. So we really can't go any further than this. Right? We've exchanged one problem. We don't know what the derivative is. For another, we don't know what the antiderivative is. Okay? So integration is not always going to work. In fact, it basically is never going to work. Okay? So unless it's dy dx equals f of x. Okay? So depending on the form of the equation, we're going to have to develop strategies on a case-by-case basis. Okay? So we're going to restrict the most general form of a first-order equation to something more specific and something which we can work with. Okay? And the first is separable equations. Okay, so separable equation is one that's dy dx. It looks pretty close to the most general form. Instead of f of xy, it's f of x times textbook if you're interested. But basically, let me show you a really quick example. Let's say it's dy dx is equal to x times y. Okay? This is separable. The strategy is you shift to differential notation by multiplying by dx. Okay? So dy is equal to x times y times dx. Okay? And then you separate the variables. So all of the terms containing y on the left-hand side, all of the terms containing x on the right-hand side. Okay? And as long as it's factorable, we can separate by dividing. So you divide by y, 1 over y, dy equals x dx, and then you integrate both sides. Okay? So these are pretty simple.